So this is 2022 AMC 10A problem 17. How many three-digit positive integers a, b, c are there whose non-zero digits a, b, and c satisfy 0.abc recurring equals 1/3 times 0.a recurring plus 0.b recurring plus 0.c recurring? And it says the bar indicates repetition. Thus, 0.abc with a bar on top of a, b, and c is the infinite repeating decimal, 0.abc, abc, 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 etc. Okay, so after reading the question, let's just start by simplifying the equation, because right now we can't do much of this equation. So on the left-hand side, we can write this as a fraction. So that's ABC, the three digits together, over 999. And on the right hand side, we have 1/3 times A over 9 plus B over 9 plus C over 9. So yeah. And then we can write the place value digits of ABC. So this is 100A plus 10B plus C over 999 equals 1/3 times whatever is here, a over 9 plus b over 9 plus c over 9. And then, after simplifying the equation a bit, now let's just multiply both sides by 3. Because we don't want the 1/3 and we don't want 999. So it's a win-win for both sides of the equation. So we have that over 3. And we have a over 9 plus b over 9 plus c over 9 on the right-hand side. Now we want to cancel out the 9. We don't want the 9 either. We don't really like fractions in general. Let's multiply both sides by 9. We have 100a plus 10b plus c over 37 equals a plus b plus c. Again, we don't want the 37. Can't really work with it. It's like a prime number that is really random. So let's just multiply both sides by 37. So we have all integer coefficients. Okay, so on the right-hand side, we have 37a plus 37b plus 37c. So this is where it gets hard. So now we've done the easy stuff by simplifying out the equation and things. Now we want to solve this equation for all possible values of a, b, and c and count the number of values for a, b, and c that are non-zero that work. So firstly, I want to move the like terms on one side. To ensure that the coefficients are still positive, I'm going to move 37a to the left-hand side. So this will give me 63a. And I'll minus 10b on both sides, so this is 27b. Plus minus c on both sides, 36c. So that is that. And then now we can start solving. But before that, just notice we want to simplify the equation as much as possible. So we can divide both sides of the equation by 9. So this is 7a equals 3b plus 4c. Okay, so now there's a really, really immediate solution here for a, b, and c, which is just 1, 1, 1. Because if we plug in 1, 1, 1, this is just 3 plus 4 equals 7. Really simple math. Okay. So our first solution is 1, 1, 1. And obviously 2, 2, 2 also works because that's just multiplying both sides of the equation by 2. 3, 3, 3 also works. So does 4, 4, 4. So here we just have 9 solutions directly from 1, 1, 1 to 9, 9, 9. And then here, what I did was I just chose A, which is 9. But that was just wrong because there were still more solutions that we've excluded, although those solutions are way more or less obvious. So we want to find a value where b, c, and a are non-zero, but b and c are different values. Because we've already had all the cases where b and c are the same values, 1, 1, 2, 2, all the way to 9, 9. Okay, so let's try this out. Let's first try it when a is 1. When a is 1, we have 7 equals 3b plus 4c. So 7 is... but we know that the only way you can write this out for b and c being numbers between 1 to 9, because it's non-zero, is to have 1, 1. It's to have 1, 1. That's the only solution. So a equals 1 doesn't give us any extra solutions. But when a equals 2, so we want to make 14 with 3b plus 4c. Now, let's see. So if we subtract 3 from both sides, we have 11 is 3b minus 1. 3b minus 1 plus 4c. Now, b minus 1 can be 0. We're fine with that because we're okay with b equals 1, right? So that's okay. But can 4c make 11? Well, no. Okay, we can try subtracting. We can try subtracting 3 one more time. So that gives 8. This equals 3 times b minus 2 times plus 4c. Here 4c equals 8. That's possible. C just equals 2. But the problem is, if c is 2, then b is also 2. Because b minus 2 is going to be 0 then. And we already have the solution 2, 2, 2 over here. So that doesn't really do anything. Okay, so let's try this again. And this obviously doesn't work. 4c can't make 5, and this also doesn't work because 4c can't make 2. Okay, so what about when we subtract 4 from the equation? So we have 10 equals 3b plus 4 times c minus 1. We have 6 equals 3b plus 4 times c minus 2. But notice that this is just the same thing because if we find a solution of bc over here, it's gonna appear in the solution when we find for bc, when we subtract 4 from the left hand side. So let's try a equals 3. When a equals 3, we have 21 equals 3b plus 4c. Notice right away that 21 is a multiple of 3, so we can have 3 times. So we can have 3 times 7. So b equals 7 and c equals 4, and a equals 3. This might be a solution, but wait. Why is c equals 4? Okay, here c is equal to 0. C equals 0. But this might be a solution, but however, the problem says that a, b, and c have to be non-zero digits, so this doesn't work well. This doesn't work as well. And if we try whatever we did above here, this doesn't work for 21 either. So now we're tempted to give up and just choose 9, but just don't give up because the question is definitely not going to be that easy. It's question 17. So a equals 4. Let's try 28 then. For 28 equals 3b plus 4c. Notice that 28 is a multiple of 4. So we have a equals 4, b equals 0, and c equals 7. But b can't be 0. It's non-zero digit, so that doesn't work. Now how about anything else? How about anything else? So let's see. So we can try 25 equals 3 times b minus 1 plus 4c, right? We can also have 22 is 3 times b minus 2 plus 4c. We also have 19 is 3 times b minus 2 plus 4c. We also have 16 is 3 times, that's b minus 3. So 3 times b minus 4 plus 4c. Now c equals 4 and b equals 4 for 16, so this doesn't really add to any solutions. Let's keep going on. 13, 3 times b minus 5 plus 4c. 10, 3 times b minus 6 plus 4c. 7, 3 times b minus 7 plus 4c. And 4 equals 3 times b minus 8 plus 4c. Okay, so 4 works because 4 is a multiple of 4, right? Okay, so here 4 works. So we make sure that b minus 8 is 0 and c is 1. So this means that b is 8, c is 1, and a is 4. So this is a solution here. If we plug this into this equation, it works. And this is a new solution, so there's an extra solution. So we know that the answer choice here is definitely not going to be 9. It's at least 10. Okay, so this is one solution. Let me just underline it so we can count this later on. And if we move down, we have 1 equals 3 times b minus 9 plus 4c, which also doesn't work. So let's move on to a equals 5. When a is 5, we have 5 times 7, 35, equals, well, 3b plus 4c. Okay, so we want to make sure that we subtract enough 3's such that the remaining number is a multiple of 4, right? So 35, so let's see. So 35 minus 3 is already 32. Okay, so we can try that out. So we have 32 is 3 times b minus 1 plus 4c. Okay, so this means that, so this works out because c is a multiple of, so 32 is a multiple of 4. So one solution would be a is 5, b is 1, and c is 8. So this is another solution. Okay, so let's see if there's any other solutions. So we want to make sure that 32 minus something is another multiple of 4. Since 32 is already a multiple of 4, we want to subtract this by another multiple of 4. Then the lowest common multiple of 3 and 4 is 12. So we subtract 32 by 12, or by 3 times 4. And 32 minus 12 is 20, equals 3 times b minus 5 plus 4c. This works, but the solution is just 5, 5, 5, which doesn't add to anything. Let's subtract this by another 12. We have 8 equals 3 times b minus 9 plus 4c, which actually works. So we have another solution, a equals 5. Okay, we have another solution, a equals 5, b equals 9, and c equals 2. So this solution works. So what this means, and since we can't subtract any more 3's because the largest b can be is just 9, we'll move on to a equals 6. So now we know that the answer is at least, so 9, 10, 11, 12. The answer is gonna be at least 13 then. This means because we right now we've counted 12 solutions, so we need another solution or another 2 solutions for the right answer choice. So a equals 6. We have 6 times 7, which is 42, equals 3b plus 4c. Now let's just subtract some numbers first. 42 minus 3 is 39. 39 minus 3 is 36. So we have 36 is 3b minus 2 plus 4c. So this actually works out quite well. A equals 6, b equals 2, and c equals 9. That's one solution there. Let's try some other values. So 36 we want to minus 12 because that is 24. And we have 3b minus 6 plus 4c, but that's just 6. 24 minus 12 is 12. Equals 3 times b minus 10 plus 4c. That actually works out, but b can't be 10. B is a unit digit. B is a digit. It has to be 1 through 9, so this just doesn't work. Okay, so we have an extra solution right now. So right now the answer is 13, but let's see if there's any other solutions. So a equals 7. For a equals 7, 7 times 7 is 49. And we have 3b plus 4c. Okay, so 49 minus 3 is 46, minus 3 is 42, minus 3 is 43, minus 3 is 40. So let's check out 40 first. 40 equals 3b minus 3 plus 4c. So this means that we have a solution, which is a equals 7, b equals 3, and c equals 10. But c can't be 10, c is a unit digit, so let's move on. Now 14 minus 12 is 28. Let's check that out. Well, that doesn't work either because in this case this is just 7, which is our original solution. Now we subtract by another 12. We have 28 minus 12 is 16, and this, but b can't be 11, so this doesn't work, and any other values don't work. So let's try a equals 8. We have 8 times 7, which is 56, equals 3b plus 4c. And 56, so for 56, 56 is a multiple of 4, but we know that b can't be 0, so we need to subtract 12 first. Subtracting 12, we have 48. Wait, no we don't. Subtracting 12, we have 44. So we have 3 times b minus 4 plus 4c. But in this case, c is going to be 11 for 4c to be 44, so that doesn't work. Let's subtract another 12. We have 36. Wait, no. We have 32. So we have 3b minus 8 plus 4c. But in this case, b is 8 and c is 8, so this doesn't work. What about 20? We have 3 times b minus 12 plus 4c, which doesn't work as well because b can't be 12. So last one, a equals 9. 9 times 7 is 63, which is 3b plus 4c. 63 minus 3 is 60. So, yep, there we go. But here c has to be 15, but it can't be 15. It has to be 1 to 9. So this doesn't work. Let's subtract 12. We have 48. And so this is 3b minus 5 plus 4c. But here c has to be 12 for 4c to be 48. So this doesn't work as well. Let's try 36. We have 3b minus 9 plus 4c. b equals 9 and c equals 9. So this is just the original solution. And if we subtract another 12, we'd have 3 times b minus 13, which doesn't work as well because b can't be 13. b has to be 1 to 9. So, and we've tried all the digits of a, so there's no other solutions. So let's just count the total number of solutions. We have 9 solutions plus 4 extra solutions over here, underlined in blue. So 9 plus 4 is just 13.